Hi, I'm Paras Agrawal. I am founder of AmplifiU AI, and I have got Sulbha, our learning design specialist, with us. Hi, Sulbha.
Hi everybody. How are you, Paras?
I'm very well. Thank you. How are you?
Good.
Hey, Sulbha, we have been receiving a lot of requests from teachers about NEP. So we thought of doing a series on helping teachers about NEP alignment, what it is, how they can do, what tips and tricks they can apply in their classrooms to align their resources for NEP. What do you think?
Hmm. So, Paras, very interestingly, very recently, Volt Learning had organized a webinar with Mr. Ganguly. And as you know, Mr. Ganguly is one of the very renowned names in education department. In fact, he was one of the members of the steering committee for NEP also.
Mhm.
And one of the very interesting things that he said right at the beginning was how he is envisioning this entire experiential learning thing happening. And one of the important points he made was that now we need to change our approach from deductive to inductive pedagogy.
Interesting. Deductive pedagogy and inductive pedagogy. So what does that
Yes.
mean? Can you explain a
Okay.
little bit about that?
Sure. So let's say, when we talk, let's talk about our times, right? When we were learning, what was the teacher doing? The teacher was basically giving us a concept, and then we were rote learning it, and then we were like moving forward with it, right? Now think of this approach like a deductive approach. So deductive approach was more traditional, where it was very teacher centric. So the teacher was the hero, right? And she was the one who was kind of bringing a rule or a principle or a theory in front of us, introducing us, and then we were only seeing how we can apply it.
Yes, I remember, teacher would come on classroom, they would write,
Yeah.
some theorem or a principle on the board, and then all the discussion starts happening around it. What is this? Who coined this term? Who invented this
Yeah.
thing? Who discovered this principle and all? And then all the discussions happens around that. So
Yeah.
is this deductive?
Yeah, this is deductive method. But what we are trying to do with NEP is we are trying to change this to an inductive approach, which is going to be more exploratory in, like, as you know, right? Experiential learning is very big thing with respect to 2020 NEP.
Right.
So you're in like the inductive method, what we are trying to do is like, let's say I observe something, I
Hmm.
observe a pattern, or I just see something around me which is making me curious. So
Right.
obviously I have got some questions around, right? I identify a problem. Like last time we spoke about SDGs, right? So that's a problem. Now I am observing this particular problem, so I will observe and make my own deductions. I will make my own conclusions after studying a certain pattern,
Right.
right? So this is what would be inductive. And it's very interesting, because it is child-led.
Hmm.
It's their curiosity. So it's the natural way we learn anything, right?
An interesting one. And if I'm
Yeah.
thinking about it, I realize that it would encourage more critical thinking, more
Yeah.
creative thinking, because every student will try their own way of thinking to solve that problem in their own context with their own understanding and knowledge. Instead
Yes.
of teacher telling the same concept to everyone, because every student is different. And I think this will encourage students to think in their own context and apply their own creativity and again, even examine the facts and observations critically in their own ways.
Yeah, and I think with this kind of a methodology, the real world context that we all are striving to achieve, right? Like the gap that we see between theory and practical, I
Mhm.
see that this has a very good bridge between that, right? So it is going to add a lot of value, I feel.
I'm very curious right now to explore this further, and
Yeah,
I'm itching to try it on AMP and see if we can explore this, brainstorm about this, and do
why
something.
not?
Do you?
Why not?
Shall
Please,
we?
please, let's go ahead. Yes,
Let-
yes, yes, yes,
Oh
yes.
my God. Let's try. Let me share
Yeah,
my screen.
yeah,
So you can see my screen now?
yes, I can.
Okay. So shall we try for brainstorming? Shall we try blank template?
Yes, I think let's go with a blank template. Let's see what it does.
Right. And teachers, this is a very versatile template. It's like a blank document that you have with AMP powered blank document where you can brainstorm with AI. You can change anything, you can edit anything, and you can keep extending it the way you want.
Yes,
So let's maybe try a topic for inductive versus deductive.
yes,
And I want
yes.
to make it as, for example, heading. And I want to make
Hmm.
it as maybe center line on the page. And I
Yeah.
will also make it maybe purple. That's two. So what do you want to brainstorm?
I am curious to know how we could apply this to abstract concepts. Let's say, I don't know, Pythagoras theorem, maybe.
Yeah, in fact, students all most of the time they ask, we are learning Pythagoras theorem, but how will I apply that in my real life? What's the
Exactly.
applicable? What's the applicability of it?
Hmm.
What's the use of it? Why we are learning that? And often teachers say that, you just have to learn it. That's part of the
Yeah,
curriculum. So, but again, I think
because
with
it's a part
this,
of the curriculum.
yeah. So let's try that, shall we?
Yeah, sure.
Anywhere on the page, I'll just press a space bar and AMP is available.
Yes.
Let's ask AMP, how can I introduce an abstract concept like
Hmm.
Pythagorean theorem using inductive method? Shall we?
Right. Yeah, let's do that.
So now AMP is going to go through it and give us some examples. Okay.
Okay, I just loved, I mean, I can't see the entire response yet, but what I loved is it started with introducing the method. So, just in case if the teacher is not sure what exactly it would mean, it's also giving it a good definition, right? It's saying that
Hmm.
it means guiding students to discover the role themselves through patterns, examples, and hands-on activities. That's
Hmm.
wonderful.
Right. So in fact, you can highlight that as well.
Yeah. Panos, did you notice one more very interesting thing that happened right now?
Mhm.
We had not told Am that which age group we are looking for. And
Yep.
it actually took the right age group, 8 to 10.
Right. Because I think because of the Pythagorean theorem,
Yeah, I
when
think
it
it
is
just
introduced in
mapped
the
it to the.
classrooms. Yep.
Yes.
This is what
Interesting.
happens when you build something which is aligned with the curriculum.
Yes,
Hmm.
correct. And against, I'm just thinking like if I would have used any other tool, maybe I would have to feed it with lot of data as to,
Prompting.
what age group and lot of prompting. And you know that, with every new model coming up, the prompting patterns are also changing,
Change.
right? So, I mean, it's difficult, but yeah, I think AMP is doing a fabulous job right now. This is wonderful.
So ask students to
Areas of
measure the
square.
sides and record their length in a table. So this is observation. So measurement and observation, which are part of the NEP as well.
Yeah. I'm
Mhm.
just thinking that, can AM generate like an observation table for us?
Yeah, absolutely. And can create an observation table as well towards the end or here. Do you want to create?
I think step number two, right? Because that's
Yep.
where we want them to.
So do you want to first create an observation
Yes,
table?
yes, yes.
I should have actually called it for step two. Let me call it create an observation table for
Areas of square.
step two.
Acha, step two. That's fair.
Now, the beauty of this is you can keep tweaking the
Hmm,
instructions till you get the right answer.
correct.
So
And we
instead
can,
of
of course, make the edits in the document. So
yep,
that
instead of
helps.
piling up everything in different conversations and copy pasting, you
Hmm,
can do all the tweaking at one place.
yes,
So here's an
clean.
observation table for area of squares. We can keep it and then we can make changes if we want here.
Hmm.
Now we have got the observation table. What do you want to do? Shall we compare this with the deductive as well?
Sure. I think that would be a fabulous idea. Since we
Okay,
started with that question of the difference between inductive, deductive, I think this would be great.
right. So we know what inductive is and how a student will start with that, observe, and then find their way to prove the formula.
Yeah.
Let's go with deductive now. Okay.
Hmm.
Make it bold. For example, ask the same instructions to AMP
Yes.
for deductive method, starting with a general principle, rule or principle,
Yeah.
then showing how it applies to specific examples. And here's the approach. Let's see.
Awesome. So as we said, right, that we'll be given the formula directly
Right.
and then explain it and then move further.
Right. So it starts with the theorem, while the inductive is you keep adding things towards that
Yes.
theorem. So this
Perfect.
deductive is more like working backwards. So you know
Yes.
what the end outcome is and you are working backwards from it. While the
Correct.
inductive is you are exploring your way,
Moving
finding
forward.
your
Yeah.
way towards the end outcome.
Yes.
This is fantastic. So Sulva, now we know what is inductive pedagogy and what is deductive pedagogies. So teachers, you can apply this in your classrooms, in your own context with your students, and tell us how it works, what the outcome is, how engaged the classroom was, and what students felt about it. What do you think, Sulva?
Yes, absolutely. And keep writing to us about the challenges that you face in your classroom, and we'll be happy to address them. So I'll see you in the next video. Bye bye. Thank
Thank
you.
you. Bye-bye.